So hello everyone, my name is Chris Doran. I am a technical sales specialist for Global Test Supply. Thank you for joining us for a webinar today. This is brought to you by Global Test Supply University. Today's topic is condition monitoring with thermal and acoustic imaging with Teledyne Flear. We're going to be covering a good amount of information over the next 40 to 45 minutes or so, and we do have time allotted at the end of the presentation for some Q&A. So we are going to encourage you throughout the presentation, please use the chat feature or the question and answer feature to submit any and all questions that we have. We want to try and take full advantage of having an expert like Russell on with us today to get all your questions answered. Global Test Supply and Teledyne Flear have been working closely together for many years. We pride ourselves on being a leading distributor of Teledyne Flear in the US. This is a result of our dedication to offering you our product expertise, our service, and our competitive pricing. As mentioned, today's webinar is presented by Russell Hall. He's based in Wisconsin and has been a channel partner manager with Flear for, I guess, over 2 years now. So Russell, the presentation is over to you.
All right, thanks a lot, Chris. Appreciate everybody hopping on today and learning a little bit more about condition monitoring. I am going to kill my camera just for now to increase the bandwidth and then make the screen and the presentation a little bigger on your computer. So I'll go ahead and close this webcam out. All right, and Chris, you can see my screen, correct?
That's correct.
All right, we'll jump into it. So first a little bit, just quick agenda here, what we're going to cover today. First, who Teledyne Flear is, condition monitoring and predictive maintenance, why it's important, some common challenges that we see in the field that you might be experiencing, and then some predictive maintenance solutions that can help you with your condition monitoring and your predictive maintenance program. So we'll dive in specifically to thermal imaging and acoustic imaging. As Chris said, I'm a Flear sales rep located in Wisconsin. I've been with Flear for about over like 3.5 years now at this point. So Teledyne Flear, we were acquired by a group called, or we really merged with a group called Teledyne. This happened last year. So now what it was traditionally Flear, Flear Systems is now Teledyne Flear. Our offering and our portfolio really remains the same. And then with joining forces with Teledyne, they do a lot of other sensing in gamma rays, X-rays, and other visual spectrums as well. So it's really like a nice merger here that happened. But Flear, we still have 6 main verticals: condition monitoring, optical gas, public safety, fire cameras, cameras for police officers, security cameras, research and development, and then also we have electronics. So what we focus and what we're going to talk about today is condition monitoring. These solutions are many of these other solutions are also offered by Global Test Supply. So condition monitoring, what is it? It's the measuring of specific equipment parameters, temperature, vibration, sound, and noting any signs of significant changes that could be indicative of an impending failure. So it's a critical task that can ensure your power keeps flowing, machines keep working, your equipment lasts longer, and your company avoids costly breakdowns or unexpected closures. When done right, you can improve your safety and sustainability, your productivity and quality. You can lower your capital and operational costs, and then ultimately lower your business risk as well. So at the root of it, we're keeping your facilities running and your people safe. Condition monitoring can be applied to many different markets. So no matter who you are on this call, thanks for hopping on. If you're a utilities person or manufacturing, facilities, building, really wherever you are, condition monitoring can be applied to make your business run more efficient. some of the different technologies. And again, today we're going to talk about thermography and acoustic imaging, but there's also a lot of vibration monitoring systems that we have and other test and measurement tools that can go into a well-rounded condition monitoring program. So the big thing with condition monitoring, what you're trying to avoid is unplanned downtime. And that is time that occurs unexpectedly as a result of a failure. There's many different categories of unplanned downtime, and here's just a few. You could have excessive tool changeover, right? When you have to change over that tool from making one gizmo to a different gadget, right? That might be unexpected downtime. A job changeover, same type of thing. Lack of an operator. Your shifts run, 7 to 3, 3 to 11, 11 to 7, and somebody doesn't show up and you can't get that machine running, right? Well, that's unplanned downtime. You were planning on that person showing up to work on time that day to start their job. So there's many controls or standard operating procedures that you might have in place to avoid those types of unplanned downtime. Make sure that your scheduling is done right. As jobs come in, you're building out your work in the most efficient manner possible. All of these sort of things that increase your efficiencies. The same should be applied to your machines and your electrical equipment. Because you could have unplanned downtime with a machine going down as well. There's a study done by an analyst firm called Aberdeen Research, and they looked at a variety of different companies over a 3-year time frame, and 82% of those experienced unplanned downtime that cost upwards of $260,000 an hour. So it could be very costly, which goes right to your bottom line. When we talk about equipment, your manufacturing equipment, your electrical equipment, right? Everything really has a life cycle. And we look at equipment life cycle with this chart here, the DIPF chart, the DIPF. So when you first install, or when you first create a design of your equipment, right? That's the design phase. Then you install it. So if somebody makes it, you bring it to your plant floor, you install it. At that point, you expect that piece of equipment to be running fine, to be running smoothly. Like when you buy a new car, you expect to be able to drive it off the parking lot and everything work. And then we get to the P phase. So that's sometime after you installed it, you've been running it for extended period of time, and now you can maybe start to see something degrade in that equipment, or in your new car, right? You're going to need to get the oil changed, or maybe change out the brakes, or maybe tune up your engine. So this is the point at which failure can begin to be detected, and there are many different ways to detect that failure. We see a couple of them here. One, ultrasonic spike, vibration analysis, and then also thermography. So you get to the point at which failure can begin to be detected. You can do your predictive and preventative maintenance in that phase. And then ultimately, you're going to get all the way to the F, where you have a functional failure. So this is where the whole thing is, basically gone to crap, and it's not going to work anymore. You got to change it out, get a brand new one. So all of the equipment is going to follow some sort of life cycle where it's going to no longer be operational. So with condition monitoring, we're trying to extend that life cycle and save you money throughout the course of that lifetime. So here we have a chart that analyzes the cost per horsepower. And there's different ways that you can treat your equipment. So we have a couple different scenarios here. You can run your equipment to failure. So run to failure, and then you maintain it. So basically this is saying we're going to turn it on, and when it stops working, then we'll go inspect it and try and fix it. That's going to cost you $18 per horsepower per year. So if you have 1,000 horsepower in your plant, which isn't that much, maybe that's just one machine, that would be $18,000 that you're going to put into fixing that machine. You can also do time-based maintenance. So this theory is every month, or once a week, or once a month, or once a quarter, I'm going to go out and inspect this piece of equipment and see if it's operating effectively. Now, this is a little bit better than your run to failure because you might catch something before it happens, but also you might be planning this maintenance in a time where it's not needed. So now you're using some of those resources, that person or those people to go inspect it, maybe the downtime that is planned, but wouldn't have had to be downtime because the piece of equipment is running smoothly. So a little bit better than just letting it run to failure, but we can still do even better than that. Condition-based monitoring is when you actually monitor the equipment to track loss of performance. So now here you're cutting your costs from run to failure in half. And then really expanding upon that is proactive maintenance. So it's a combination of condition-based monitoring, and then proactive is really digging into the root cause. So why did this, right? We see it degrading, and then why is it degrading? Is there something that we can do different to prevent this from happening again? So that's really the ultimate goal, is you're trying to get to a condition and proactive-based maintenance program. You're monitoring the equipment. It starts to heat up, right? Or it starts to vibrate, or it starts to make some acoustic sound. Now you say, hey, this is an indication that something's not going right. Let's get somebody out there, check it out, and fix it before we have a catastrophic failure. When you can do that, what you're going to do is increase your mean time between failure, or your MTBF. So what that is, as you look at this chart, we have the green dashes here. That's when your system is running and it's running smoothly. And then something happens unexpectedly and your system fails. Now you have downtime. You got to go and fix it, repair it to get it back up running again. And then you start running again, you have this green dash. So the goal is to increase the length of the smooth operating machine, and really minimize the amount of time that you're down. So what we're trying to do is increase the mean time between failures. When you do that effectively, you're going to drop all of those costs that we see in this chart. You're really going to start to get down to that $9 or $6 per horsepower. Some common challenges, and this is straight from a maintenance reliability engineer at General Motors, a customer of ours that we worked with. This is just an email from him that he sent us, and what they're trying to accomplish with their cameras. They're trying to put in place this predictive maintenance program, but some common challenges that they had is that they don't have enough people on the line usually all times to catch all the to do the predictive maintenance. Sometimes they have so few people that they're just putting out fires, right? They're just running around putting out fires. Another challenge is they're losing a generation of skilled workers with not that many new candidates coming into the field. So they're worried about being able to replace all those people. So what they're trying to do to accommodate for some of these challenges is really create this predictive maintenance program that's going to save them time, save them energy, and ultimately keep their facility running more smoothly by doing this predictive, proactive work, and not just running to the next headache, to the next headache, to the next headache. They're trying to get in front of it. And so again, this is something that you guys will be able to do as well. So Flear, we have solutions, products across, like we said, many different markets, whether you're manufacturing, commercial building, school maintenance, whatever it is. We have a lot of these solutions available that will help you with your predictive maintenance program. And then today we're going to dig into a couple of these technologies just a little bit deeper. So the first is thermal imaging. So why is thermal imaging useful? Heat anomalies tend to indicate problems, and as you can see by the two pictures here, just like a person that spikes a fever, if your fever starts raising, your internal body temperature starts raising, that probably means that you're sick. Our mechanical and electrical equipment is virtually the same. once the temperature starts rising, that probably means that there's a problem, right? And undiagnosed, that small problem can become a big, more catastrophic event. Thermography as well, it's non-contact. So you as the user controlling that camera, you can stand from a distance away from the target or the asset, as like we like to call it in thermography. So one, you can be separated from that, maybe energize equipment. You don't have to be as close to it. You eliminate some of that danger. The other thing is by taking a non-contact reading, you're not changing that piece of equipment in any way. You don't have to touch it. You're not manipulating that that asset in any way. So you're getting a true reading of how that asset is performing and the temperature of it. Thermography is also two-dimensional. So you're taking a picture, right? We see pictures in 2 dimensions. So this image right here, as you can see, this was a flood. So this is a big flood that they had, and all the blue and purple areas. That's how far the water went, and so it's easy to visualize, what the problem is and how far it went, in this image. So if you had to cut out all this carpet, well, you know that all this blue and purple area, all that carpet has to go, but maybe you can salvage some of the stuff where the water didn't seep that far. Same thing on the walls. Maybe you're going to lose the, 4 inches, 6 inches, 8 inches of, the bottom of that drywall because it's wet. You don't want it to turn into mold. But now you don't have to replace that entire wall. Maybe you just cut out, up to that 10-inch or that 12-inch mark. You rip that stuff out, you replace that, you're good to go. You're going to save more material, you're going to save more time by having this nice two-dimensional image. It's easy to read, it's easy to comprehend. And then here's just a kind of a cool video. This is actually a drone being piloted and coming back down to landing. So thermography, it's real time. You can scan fast-moving objects or stationary targets at the same time. As you can see on the left-hand side in thermography, you can see that landing strip from a long ways away. On the right, with just the visual, you can see some lights, but you're not really sure where that landing strip is until you get a little bit closer. So that thermography gives you a lot more detail, or it can give you a lot more detail than just a visual camera or a visual image of an asset. So as this drone comes down to landing, right now we can definitely see on the right-hand side, where the landing lights are and, where to put this thing down. But using the left as well makes it a lot easier to see it from a distance. Thermography, maybe the biggest benefit is that it presents a lot of safety for you, for your facility, and for your workers. You can identify potential hazards, before opening electrical equipment. So this box that we see here on this bar, obviously on the left and the thermal pattern, you can see that the surface of this box is 81.7 degrees. And some of the ambient temperature right there is, 74.9. So about a 7-degree delta between that box and its surrounding, which is a lot because this is also the outside of that junction box. Once they went in and actually opened up this box to see why this was heating up so much, actually inside was more than 175 degrees above that. So very hot components, a loose connection, a bad connection that was causing that. But before they went and opened that box, before they went and did that inspection, they kind of had a good idea of what was inside of that. And so they were able to take the necessary precautions, knowing what kind of situation they were walking into. Here's another example of these 3 fuses here. When they originally looked at this fuse block, they thought the issue was kind of right up here at the connector. As you can see, the fuse here on the left is a little bit warmer. But as they dug more into this, you can see the wire coming down here. The wire leading up to this connection is in this bright red, way hotter than the other two wires over here, there's actually an issue further down downstream that was leading to this issue. So again, thermography is useful. You get this nice image. It can pinpoint where the problem is coming and where it's going. Here's some more cables in this junction box. The load current was almost equal across these 9 different cables, except for this one kind of right here in the middle. And similar to the last image, you can see as we go down this cable, the color is getting brighter and brighter and brighter, indicating that it's getting hotter and hotter. There was actually an issue about 100 feet away from this junction box that was causing this overheating. So we're able to see it here, and then we're able to trace it, back to its root cause, make that fix, make that correction, and then everything was good to go. Left alone, left unattended, this would have became a major, a major disaster. Potentially an electrical fire, overheating at this junction box. So infrared, there's many different applications for infrared: electrical, mechanical, building applications, petrochemical, and variety of others. It's not uncommon that I go through a week of work and somebody asks me, "Hey, can your cameras help me with this?" And it's something that we never really thought of before. So it's a really cool technology. It can really save you a lot of money and efficiencies in your place of work. So how do the cameras work? We'll dig into a little bit how they actually function. So IR waves are emitted by all objects. It doesn't matter if it's a cold object or a hot object. IR radiation or IR waves are emitted by all objects, and with temperatures, they are just more impactful, right? They're bigger, they increase. So with this cold glass of water, it's putting out some IR waves, but not many, right? But then with this fire, we're getting a stronger presence of that IR radiation because the fire is burning, because the fire is hot. So our cameras have detectors on them, and so when these photons hit our detector element, we take that, and there's a smart guy, Stefan Boltzmann. He created this law a long time ago that takes that IR radiation and converts it to a temperature. And now each one of our pixels on our detector takes what they're looking at and converts it into that temperature, and then based on what the temperature is and the scale of the environment, they will create a picture, right? So depending on the temperatures involved in that scene, they will change color and then give you a nice picture right here. So again, the IR waves hit our camera detectors, we convert that into a temperature reading, and then that temperature reading is translated into a different color based on the palette that you've chosen. One of the biggest things to take into account when you're looking at thermal cameras is the IR resolution. So this box that you have that we have right here on the left, this big box with the grid inside of it, this might be a somewhat low density IR resolution. The one now that I have on the screen is a higher density, or more pixels in that same space. So the two main boxes are the same size, and now we just have a lot more pixels inside of that same size space. The more pixels that you have, the higher density of measurement points you're going to have, the more accurate your reading will be, and the more temperatures you'll be able to pick up. And so here's two cameras side by side, the Flear camera on the left, competing camera on, or the Flear camera on the right, competing camera on the left. As you can see, with a little bit more resolution on the right, we can actually see where this fuse is heating up. We can almost actually count the fuses and definitely identify where it's coming from. We can also even see the cable, right, or this wire that's coming into this panel. So we can see that wire. On the left, you can see that it's picking up some some temperature rise, but it's hard to pinpoint where that actually is happening. So yes, we can see a temperature rise, but we lose a lot of that detail because there's not enough pixels in this camera to kind of really pinpoint where that's coming from. Again, you can't see any of these wires coming into this scene, as well as the camera cannot detect that temperature difference. So here's a look at, in a little more detail. Here's a series of motor banks, and then on one of these motors we have a spliced wire. And so then we'll kind of look at this in different pixel counts. So when we have a small pixel count, this is 1 pixel, right? This blue box is 1 pixel, and it's going to take the temperature of what's inside of here. So we're getting some of this green, some of this blue, averaged in with the white and red. And so when we do that, we're not going to feel the full effect, or we're not going to see the full effect of the temperature of this. We don't have enough pixels on target. That's another common phrase, how many pixels are on the target. When we increase our pixels, so we went from 1 to now we have 4 different pixels on that target. Now we're getting a little bit more detail. Each pixel is picking up a little bit more temperature. So now we went up to 98 degrees Fahrenheit. So from 79 or 80, now we're up to about 98 degrees Fahrenheit. Now if we get even more pixels on that target, now we got 9 pixels inside of that same space that we've been looking at. Now we're getting a reading of 119 degrees, because now each one of these pixels is small enough that it's just hitting the hot spot of that wire and not bringing in as much of that, the green and the blue into the scene. The pixel is small enough that it's picking up exactly what is on that wire, which is our region of interest. So we went from 79 degrees all the way up to 119 degrees, so 40 degrees higher or more accurate, just by getting more pixels on target. So when you're shopping for your thermal camera, it's important that for your application, you have a camera that will give you, an accurate enough reading that you're going to have enough pixels to fully do your work. Another thing, when you're looking at cameras, a lot of our cameras have different lenses that you can get with them. And depending on the lens that you have, will also alter or improve your reading. So here with a 45-degree lens, and again, each one of these images is taken from the same spot. So we're not moving closer, we're not moving farther away, we're standing at the same spot, just changing our lens. So our 45-degree lens or a wide-angle lens, right, can see this box, and we can see that, something's a little bit hotter over here inside box 1. We got a reading of 181.4 degrees. Now we strap on our 24-degree lens, so it's going to bring it in, narrow that lens, not necessarily zoom, but bring more pixels onto that target. And now we can see that inside that box 1, we're going up to 188.5 degrees. Now we get our narrow focus lens, like a 7-degree lens. Now you can see, again, we're standing at the same spot, just the lens is more powerful, it can get closer and more pixels on target. Now we can see that inside here, box 1, the average temperature is 192 degrees. So that will help you with your decision making, right? Having the right resolution and the right lens will help guide you and give you a better picture of what is going on in your scene or on your target. Another part of our cameras, and this is patented technology that Flear has, is something that we call MSX. And what MSX does is it etches out key visible details such as numbers, labels, etc., on your target, and actually overlays it onto the thermal image, and it makes it a lot easier to understand what you're looking at. And here's a quick little video of how that works. So we have a visual image. We take the etchings of that visual image and then superimpose them on top of the thermal image. So again, now when you look back after you take this image and maybe you send it to one of your colleagues or you store it in a library and you go back to that image a week later, you know exactly what you're looking at. and you have these visual indicators to tell you, what panel this is, what motor this is, what fuse box this is. With that MSX enhancement, gives you a lot more of those details. Another part of your condition monitoring program might involve IR windows and arc flash safety. So arc flash is a big concern. It's year in, year out. There's always arc flash incidents that result in burn injuries, hospitalizations, even sometimes fatalities. And in all of these cases, it's definitely unplanned downtime. So 98% of arc flash and electrical hazards posed during an IR inspection are made possible when the panel covers and doors are removed or opened. So if you can always keep that panel door closed, you're going to eliminate about 98% of arc flash incidents. Once that panel is open, it's a lot more danger to yourself and to the people around you and to your facility. So with an IR window, it allows you to do these inspections with keeping that cabinet door closed. It keeps that worker isolated from that live switchgear or that panel, ultimately reduces the risk associated. So as we're looking at these hierarchy of controls, right, PPE, for instance, is the last thing, right? That's the last thing that we do. We always want to do it, but just because you have PPE on doesn't mean you're going to be safe, right? Sometimes our PPE fails. Sometimes it's not meant to protect you from an arc flash incident, right? So the more that you can get away from that danger, the better. As you do these and as you inspect your equipment, you're going to increase your MTBF, like we talked about before, your mean time between failure. Your assets will be healthier, they will run more efficiently, and you will find these problems earlier, and then you can take your time to schedule the necessary repairs. And then this IR windows, they also improve your productivity. When doing IR electrical scans with windows, it only requires one person. A lot of scans that do not have windows involve 2 or maybe 3 electricians. And so now you've just, been able to resource those people elsewhere. With the windows installed, you just need one person. Here are a couple images. So on the left, you can see with IR windows, we're able to do both thermal inspections and visual inspections. You can see on the 2 images on the left here, the gentleman there has minimal, PPE. He's got his hat, he's got his safety glasses, but because that cabinet door is left closed, he doesn't have to wear the NFPA rated PPE suit, for arc flash that we see here on the right when they're actually opening up these doors. Again, that's bringing in a lot more danger to that person, to that facility. We actually have an IR window calculator that will calculate your return on investment. So after you install these and then you want to do, monthly or quarterly inspections, you will, you're saving all that time, you're saving that extra labor. So these IR windows really pay for themselves generally in a year's time. All right, switching gears, and we will have questions at the end. So please take a moment. If you have any questions on the infrared cameras or the infrared windows, feel free to type those into the chat box, and then we will go to those at the end. But right now we're going to switch gears to acoustic imaging. Flear, we launched an acoustic imaging camera about 1.5 years, 2 years ago. And it's been, a great unit and a great addition to our solutions. So what is ultrasound? Ultrasound is high frequency sound waves that are beyond the range of human hearing. So we cannot hear them. Similar to it, like a dog whistle, and dogs can't typically hear ultrasound either, but similar to like a dog whistle, you blow into a dog whistle, you as the person blowing into the whistle cannot hear that whistle or the person standing next to you, but your dog that's 100 yards away in the dog park hears it, and comes back. Their ears are tuned at a different frequency. Same thing with ultrasound. It's tuned at a different frequency that we can't pick up. It's highly directional, so wherever that sound is coming from, it's going in a certain pattern, and it's highly localized sources. So like if you have a leak, like a compressed air leak, it's coming from that single source where that leak is. The best part about it is it provides early warning of impending failure. So when you have increased ultrasonic activity, you know that you might have impending failure or a leak that could otherwise be fixed. Some different applications for ultrasound: electrical partial discharge, compressed air system, vacuum leak systems. Those are really many of the main applications that our camera is used for, but there's also a plethora of other uses here as well. And similar to the infrared, we get people asking, hey, can your acoustic camera help me with this application? So this list is definitely growing the more and more that we get this camera out to the market and to our end users. So when we look at compressed air and kind of how that works, so you have a pressurized leak will cause turbulence, which that turbulence can be located using the ultrasonic or acoustic imaging camera. So when that air leaks into the air, finding it using any other method other than ultrasound can be very difficult, right? You can't see it. It doesn't have a smell. We can't hear it unless it's a huge leak. So it really goes, it can easily go undetected. I'm in Wisconsin again, so we're just coming out of winter, and spring has been, 30 degrees one day, 70 degrees the next, 40 degrees the next day. But in the winter, when it's cold and we have, when I have the heat on in my house, I don't have the heat on in my house and then also open up a window or open up the front door, right? I'm paying to heat my house. So I want to keep all of that heat inside the house as best as I can. Any heat that escapes, from my furnace and escapes the house, that is just lost money, right? That's just money that I'm pouring out. Now my furnace has to work that much harder to get my house back up to that 70 degrees or 71 degrees. So I want to eliminate that. That's the same with compressed air. You're paying for that compressed air if it's, if it has a leak because of a bad connection in a tube or a pipe or at the pneumatic tool, and it has a leak, right? You paid for that air, and now it's just gone to waste, right? So that's just dollars coming out of your system. The Department of Energy actually estimates that 30% of a manufacturing facility's electricity is used just for compressed air. So, not to heat up, not to turn on the computers, not to turn on the lights, not to run the other machines, right? 30% of it is used just for compressed air in a typical manufacturing facility. And then of all that compressed air, on average, a third of it is wasted due to leaks or misuse or pressure drops. So 33% of the air that you're using gets wasted. And then if you calculate this out based on a typical manufacturing facility running a 200 horsepower compressor, 68 hours a year at 11 cents per kilowatt, maybe in your area it's more, maybe in your area it's less, but 11 cents is kind of like an average. That would be costs of $38,500 that is just wasted, or otherwise you could go and find that and save that money. So here are a couple of real images from our SI-124. It's a black and white image, and then you have this kind of rainbow circle. That rainbow circle, that is where the leak is coming from. The unit, and we have a couple images of it as well. The unit's a handheld unit, one-handed use. It's got a nice big display screen. And so all you do is take this unit, runs on a battery. All you do is take this unit and you walk around your facility. You can track, from your compressor all the way to the station where that air is going. And you can track your pipes, your tubings, and see if there's any leaks. Here's another leak with a bad connection. Here's a refrigerant gas leak, and if the ice buildup wasn't a indication that something was wrong, we can definitely verify it with our acoustic imaging camera where that leak is coming from and why we have this this massive ice buildup, right? So again, wasted energy, wasted costs, and then this, really left probably unattended for a long time, or a big leak, that transpired really fast. Now you're starting to compromise the other equipment around this as well. With our SI-124, you actually get reporting and analytics, basically instantly. And so here is here's a connection at this pneumatic tool, and it will tell you the estimated size of the leak, and it will tell you the estimated annual cost, right? So you continue to use this, and you don't fix that connection, you don't change out that hose or change out that connector, right? You're going to continue to just spill money out into the facility for no reason. And it calculates, how far away you were, when the image was taken, all of that good stuff. These can be used, the SI-124 can be used up to about 300, 350 feet as well, so about 100 meters. So again, if you have systems, overhead that otherwise, you're probably not inspecting, rarely, if ever, or if you did, you needed to get, ladders or a scissor lift or something like that. Now you can take that image comfortably from the ground, right? So one, that's going to be a lot faster for you, a lot safer, a lot more efficient to do these scans in your facility. Beyond compressed air leaks, our acoustic imaging camera can also do partial discharge. So there's 3 types of partial discharge. One is corona. That's kind of like the buzzing sound that you might hear around a power line. There's also tracking. So sometimes if that energy jumps from the source to to another ground, if you will, it'll contaminate that insulated air, that insulated area. And then arcing, between different electrical components, you might have actual electricity jumping from one spot to another. That would be like an arc or an arc flash. So here, again, some real images. Here's a faulty insulator. And so the camera will give you these diagnostics, right, as you're taking that image. It will actually classify what is going on. So you have a discharge here, discharge on the surface or inside that component. Same thing here. It'll show you the magnitude of it, and then tell you what it's seeing. So a discharge on the surface or inside that component. Here's a floating discharge, and then again here you can see now it's saying discharge between components. So this is happening, between the 2 components. There's a lot of electrical activity happening there, which could result, in an arc flash. You can also put in different user inputs to the camera. So distance, the voltage that should be running, and what it is, like a cable joint, an insulator, or whatever you're scanning. And then it'll give you the severity assessment, very high, high, medium, or low. This is great. So now, if it's a low severity, maybe it's not something that you need to go and fix right now. Maybe it's just something to keep an eye on, check again in a week or 2 weeks. But if you do have a very high severity, likely something is going wrong. You might want to jump on that one a little bit quicker than something else. All right, last quick section here, but very important. Flear, we also have a software we call Thermal Studio, Flear Thermal Studio. This works now with both our cameras, thermal cameras, and our acoustic imaging cameras. So we just made that connection with our SI-124, where it is now compatible with our Thermal Studio. So it's really a nice network of solutions that can help you again in any market, any industry. So we have our Flear Thermal Studio. That's where you can do post analytics. You can create reports. We have 3 different versions of it. A free starter version. You can go on to flear.com today and download it for free. And then we also have a standard version and a pro version. The standard and pro version are sold in 1-year licenses. They also unlock a couple more features and that you can use for your reporting. We also have something called Flear Route Creator. So before you go on to a job site with your thermal camera, this is only for thermal cameras at this point, but with your thermal camera, you can say, all right, I need to inspect these 50 assets. And so you can actually load a route of those 50 assets. And as you're going through your day, your camera says, okay, asset number 1 is, breaker in, the west building. And then you say, oh, great, all right, I'm going to walk over the breaker in the west building. Boom, take that image. Once you capture that image, you can take some notes on your camera. And then once you're done, it'll say, all right, asset number 2 is, the motor in the west building. And so you can plan out your day. You can go and take those images, ensuring that you hit everything that you need to, and you're not missing any steps. And also you're doing it in an efficient manner, a manner that makes sense as you walk around your building. Like I said, the SI-124 is not compatible with Flear Thermal Studio. So you can also upload these, your SI-124, your acoustic imaging camera images, to the same software that you're using for your thermal camera as well. So this is what it might look like for your thermal camera, and using it, you're going to reduce your report time by, at least 50%, probably more. You can create your custom templates. These are all easily shareable. So you share your reports as PDFs. So if you have the software and your colleague doesn't, or maybe your client doesn't, you can still share these. They don't need the software. You share these as a PDF. You attach it to an email just like anything else. And then also on the acoustic imaging camera, same thing. You can create your custom reports that you have here. It'll tell you, the severity assessment, where it was taken, when it was taken, the distance, all that good stuff. You can type in your own notes as well. So really easy to use, intuitive, and a great program to, 1, do all your analysis, 2, store that data, and then 3, have a place to come back to and, compare it against. All right, that is all I have, Chris, and I kept it right about 45 minutes. I think we're on time here. We got about 15 minutes for some Q&A.
Pretty much on the button. Couldn't have scripted that any better. All right, so ladies and gentlemen, everyone connected, it's now time to take advantage of having an expert like Russell on with us today to answer any and all questions that you may have. Again, please use the chat feature or the question feature. We do have plenty of time to get any and all questions that you do have answered, so please get them in over there. In the meantime, if you do have any questions that come up that are product specific, whether it has to do with pricing, specifications, application specific questions, or questions about recommendations on which camera would be suitable to you, please visit our website, globaltestsupply.com. You'll find our products, pricing, availability, data sheets, everything that you can find for a bunch of the solutions that we talked about today. You'll also find our contact information to connect with someone like myself or someone from our team who can discuss with you the best recommendations for your application. We can talk about pricing, availability, anything under the sun. We can definitely work with you, and we'll be happy to answer any and all questions that you have. So we do have a few questions that have come in. Let's see. Going to IR windows. I know we discussed a little bit about different lenses and resolution. When using an IR window, is there a specific camera or specific lens that end users should be using to utilize it to the best of its ability?
Yeah, great question. I would say it's sometimes case dependent, right? But by and large, usually one of our wide angle lenses is going to be the best for you. Reason being, right, that cabinet, between the cabinet and your actual equipment, your switchgear, your panel, there's not going to be that much space, right? It's not that deep. It's not like the door is going to be, a foot away, right? It's going to be pretty close. So when you're close to an object, what that 45-degree angle lens allows you to do is see broader inside a small space. So usually, our 45-degree or our wide-angle lens is going to be recommended for those IR windows. And as far as resolution, you're going to want to be about like a 320 by 240. And that's also where our camera lineup, where you can start getting into adjustable lenses. So usually like an E76, model number E76 and above would be a good camera for IR windows, E76, E86, E96, or any of our T-series, and then with that 42-degree lens option.
Perfect. Okay, so James has a question about, it is a camera specific question, but I will, we'll lob it over here. Does Flear offer a camera that has both AI and thermal capabilities?
AI, artificial intelligence,
Yes.
and thermal. So yes, we do have a different division that we actually make some like traffic sensors, and like our security cameras, might have some artificial intelligence that'll know, like, if it's looking at a person or at a vehicle, that type of AI.
So
I don't know if that.
I'll cut you off just because James did be specific more. He's actually speaking about acoustic and thermal, not AI.
Got it. Okay. AI, acoustic imaging, that makes sense.
Yeah, it makes sense.
Perfect. Yeah, sorry about that, James. So no, we do not have one camera that does both. Thermal is thermal, then acoustic is acoustic. So at this point, maybe that is something possible down the road. I don't think it's on our, on a 5 or 10 year roadmap or anything like that. So yeah, so right now it would be, each camera for each application.
Perfect. Perfect. Moses, your question that you did, or your comment that you did submit, I'd be happy to connect with you directly, as it's a little bit more in depth in terms of an IT situation that affects you personally and or your company personally. So be happy to address this offline and get Russell or someone in the engineering department with Flear on the line to help you solve that issue. Let's see, another question that we have here. There we go. How many microphones does the SI-124 have?
Yeah, great question. And kind of in the name, the SI-124, it has 124 microphones. And so that's really kind of like best in class for that camera. And so the more microphones, it's similar to the pixels, right? We're talking about pixels for your thermal camera. The more microphones that you have, the more sensitivity that you're going to have, and you're going to be able to pick up more of those leaks or that partial discharge. So 124 microphones, again, single-handed use, pretty lightweight. It's a real neat camera to go out and do some predictive maintenance with.
Perfect. I get this question a lot, and someone brought it up here. Are there cameras that have the ability to detect both temperature and distance to give both of those metrics within an image?
Yeah, so our the acoustic imaging camera, doesn't do the temperature, obviously. It does the leak analysis, but that does capture distance. And then on our thermal cameras, yes, starting at our E54 or EXX camera series and above, there is like a laser that is used both for understanding what you're looking at, right? Pointing a laser on the wall, where you're pointing the camera, what you're looking at, and then also we'll read that distance, so it'll know if you're 10 feet or 20 feet or 3 feet away from your target.
Perfect. A couple minutes left, everyone. So if you do have any questions, please submit them now. If we don't have a chance to answer them, while all connected on this presentation, we will contact you directly to answer the questions directly. So have no fear there. Please submit what you can and what you have. Let's see. Okay. Always another great question, another question that comes up often. Calibration frequency. How often should or shouldn't you calibrate the camera? Is this something that that is recommended? Can you give a little bit more info on that?
Sure. I would say kind of like the canned response would be once a year, but I think in a lot of cases that might be overkill. Doing it once a year. If you have to keep up to to some standard, maybe the standards in your facility or for your quality or whatever, maybe your standards might tell you when you need to calibrate that camera, and so you could always go off of that. But if you're not adhering to a certain standard or quality control, a year to 2 years is probably pretty good. And assuming that it's an expensive piece of equipment, you're taking good care of it. But some quick, easy way to kind of calibrate yourself, kind of like in the field, we call it kind of like a field check, is if you take a glass of water or even maybe something with a broader rim, like a bowl of ice water, a lot of ice, a lot of water, you kind of stir it up, make sure that's getting nice and cold. And then you point your camera directly on top, looking into the water, and your camera reads, 32, 33 degrees. That's pretty good, right? We would expect that ice bath of water to be right at 32, 33 degrees. And then kind of to extend the temperature range, same type of scenario. If you get a pot of boiling water, right? Water boils at 212 degrees. So you go to your kitchen, get a pot of boiling water, point your camera at the water, not at the side of your pan or your pot, but direct line of sight to the water. And we should expect to see 212, 211, 213 degrees. If you get 205 or 220, or on the ice bath, if you're getting like 28 degrees or 37 degrees, then you kind of know that maybe your camera is due for calibration. So doing some field checks like that is a good way to test your camera and maybe extend your confidence in needing a calibration or not.
Perfect. We did have a question that came in that is more subject to a possible webinar down the line, but I did want to kind of cue it in and ask you a question. If you're taking a look at we'll use your example of the boiling water, why not point it at the side of the pot rather than directly at the water? What would the difference in temperature be, or what could interfere with the actual temperature reading?
Sure. So all objects they have, and we didn't get into it that much today, but to your point, maybe about a different webinar, all objects have a different emissivity reading. So that pot and what a pot would be made out of is escaping me. The material. What's that?
Let's go stainless steel.
Yeah. So the stainless steel, it might not absorb all of the water heat, right? So the water might be hotter than what the pot would read, or the pot could be the same temperature, but it won't reflect off the same temperature. It won't give you the same reading. Actually, I might have an image in here somewhere of I don't think I do. I have a cool image of like a grill, right? A grill outside, you're doing a barbecue, and you can shoot the top of that grill, and it'll give you one temperature. It might say like 80 degrees or something, but then actually inside of the grill, you got the flames going, and you got a temperature reader in there. It's like 350 degrees. So There's some reflection that can happen with steel and stainless steel, some emissivity factors as well that will, make your reading not the same as the water. And I guess it would be similar to this image right here, right? On the cover of this, so if we think of the cover of this, this junction here, or, electrical box, like the pot, the outside of this is only reading 81, 82 degrees, but inside, some of those components are, 250 degrees. Same thing with the boiling pot of water. So the outside will not always match what is on the inside.
Fantastic. And James, just to elaborate a little bit more, right at the end of this webinar, we will have a short survey. Please complete it if you are interested in having a topic more, on the technical side of thermal imaging and the scientific side of thermal imaging. Be happy to bring it to you. So to be respectful of everyone's time, we are just over the hour mark. So I will thank everyone for participating in our webinar today. And Russell, thank you very much for the presentation.
Absolutely. Thank you, Chris, and everybody for joining.
Absolutely. So on behalf of Global Test Supply University, again, thank you all for joining our webinar today. We hope you found it informative and helpful. We are able and here to assist you at any point. So please visit us at globaltestsupply.com. You can find out all our contact info, email address, phone number. You can connect with an expert via chat, and there are multiple ways of getting in contact with us if you have any questions at all. At the end of this webinar, as I briefly just mentioned, we will have a very short survey for you to complete. Your feedback will assist us in improving these webinars and bringing you topics of interest that you are interested in, that you'd like to see down the line. On that topic, we do have upcoming webinars over the next course of the next month, weeks or month. Please visit the training section of our website to see a full schedule of upcoming webinars and topics. And don't forget, as a thank you for attending today's webinar, your name will go into a draw to win $100 on your next online order. The winner will be announced on our social media channels, so please be sure to check us out there. Thank you again, Russell, for the presentation, and thank you all for joining us today. Wishing you a great rest of the day.
Awesome. Thanks, Chris. Thanks, everybody. Have a great day.